So in this video, we'll be finishing up our Chapter 8 series by talking about the empirical formula. The empirical formula is the formula of a compound that expresses the smallest whole number ratio. So when I look at a normal chemical compound, I don't see things like this, or 8.2, or weird numbers that are decimal places. I see things like C4, H8. I see things that are put together. So, for example, CH2O is the empirical formula for a sugar, but an actual formula for a specific sugar is C6H12O6. And if you can see here, I can divide each of these by 6. So that means it's the smallest whole number ratio, which is CH2O. Okay, so let's look at the steps that are required in order to calculate an empirical formula. The first step for calculating an empirical formula is to obtain the mass of each element in grams. If it's a percentage, you're simply going to change it to the number of grams because we always assume that there are 100 grams when doing these calculations. So for example, if you had 100 grams of a compound and 40% of it was carbon, 40 grams of that would be carbon. Okay, so the next step is to convert from grams to moles. If you're still puzzled on converting from grams to moles, there is a video for you also on the YouTube channel, and I will put a link down below for that as well. Okay. Step 3 is to divide each mole amount by the smallest number of moles, and if it doesn't equal a whole number, you need to multiply. We're going to do one example that requires the multiplication, and this is probably the most confusing step. It'll probably make more sense when we do an example question. The last step is to then write the formula with the whole number as the subscript. So let's go ahead and start a practice problem. So in this question, I have 1 gram of a metallic chromium metal is heated with elemental chlorine gas, and 3.045 grams of a chromium chloride compound results. Calculate the empirical formula of the compound. So first of all, everything's in grams. So that makes my life easy. So let's go ahead and write that we have 1 gram of chromium, which is Cr, and it's heated with elemental chlorine gas, and the total compound, that's what this means. This is the whole compound. That is both chromium and chlorine. So if I know the amount of chlorine, then I'm going to automatically know the amount of chlorine. Okay? So if I have 3.045 grams of the chromium chloride compound, and 1 gram of that is chromium, 3.045 minus 1 is going to give me 2.045 grams of Cl. So now I have my 2 gram amounts, and what I'm going to do is convert these to moles according to step 2 of my list of the way to calculate an empirical formula. So for chromium, the molar mass is 52.00 grams, which is coming from the periodic table, and that's equal to 1 mole. Okay, and on the bottom, I have chlorine, which is 35.45 grams in 1 mole. So now I'm going to get out my calculator. I'm going to calculate the number of moles of chromium and the number of moles of chlorine. So I have 1 gram divided by 52.00, and I'm going to get 1.92, because I have 3 significant figures, times 10 to the negative 2 moles of Cr. And for chlorine, it's 2.045 divided by 35.45, giving me 5.76, this would be 9 here. Yep. 769 times 10 to the negative 2 moles of Cl. My smallest number is the chromium, so I'm actually going to divide both numbers by the number of moles of chromium. Here, this is going to give me 1. And here, you can actually see that it's pretty close to 6 divided by 2 here, which is going to give us a whole number right around 3. And if you put this in the calculator and you see that your number is like 1.99 or 2.99, that is trying to tell you that it's 3. It is a whole number. So when I write this out, it is CR/CL3. Notice that the 1 is implied here, and the 3 is actually written here. So that is the empirical formula of this compound. Okay, so now we're going to move on to the next question. I'm going to give you a couple of seconds. I'm going to read it to you, and then I hope what you're going to do is stop the video, try to calculate the empirical formula yourself, and then watch the solution for the video. So an oxide of aluminum is formed by the reaction of 4.151 grams of aluminum with 3.692 grams of oxygen. Calculate the empirical formula for this compound. A little word of warning before you start to do this calculation. This does not say the total compound. They're actually giving you the individual numbers without having to subtract. So that's something that you're going to want to keep track of when you're doing these calculations. So here's your starting point. I hope that you're going to go ahead and give this a try. Okay, so hopefully you have some kind of answer, and now we're going to go on with our next step. We've already gotten through step 1, we have the grams of everything. So now we're going to calculate the number of moles. Oxygen's easy, we know that's 16 grams in 1 mole. And aluminum is 26.98. Again, we're going to pull out the calculator and calculate what our mole amounts are. So I have 4.151 divided by 26.98. I have 4 sig figs here, so 0.1539 moles. And I have 3.692 divided by 16.00, which gives me 0.2308 moles. This is the smallest number of moles, so I'm going to divide them both by that number. So this is automatically 1. And this comes out to 1.5. Like I said in the list of steps, if it doesn't come out to a whole number, you're going to have to multiply so that it comes out to that. So in this case, it's pretty simple, because 1.5 times 2 is 3. But if I multiply the bottom one by 2, I also have to multiply the top one by 2. So 1.5 times 2 is 3. 1 times 2 is 2. So my final formula becomes Al2O3. If you think back to our naming and formula writing, this should make sense, considering that oxygen is usually -1 and aluminum is +3. All right, we have one more practice question. And this is the one with the percentages in it. So it says a compound shows the following percent composition: 71.65% chlorine, 24.27% carbon, and 4.07% hydrogen. What is the empirical formula for this compound? Like I said before, all you have to do is take those percentages and go ahead and change them to grams, because we're assuming that there's 100 grams of a compound. So if I have 100 grams of this compound, 71.565 grams is going to be chlorine. So 71.65 grams Cl, 24.27 grams C, and 4.07 grams H. I hope you're going to take a moment now, pause the video, and work on converting each of these gram amounts to moles. All right, I hope you've taken a moment, you paused the video, and you have written down the following things. So we're going to divide the number of grams of chlorine by 35.45 grams to get 1 mole of chlorine. You've divided carbon by 12.01 grams to get 1 mole of carbon. And you've divided hydrogen by 1.01 grams of hydrogen to get 1 mole of hydrogen. Again, we're going to put these into our calculator so we can figure out how many moles in each element we have. So 71.65 divided by 35.45, and I get 2.012. This is mole Cl. I have 24.27 divided by 12.01, and I'm going to get 2.021 mole of C. And 4.07 divided by 1.01 is 4.0297, which actually rounds to 4.030 moles of hydrogen. My smallest number is chlorine, so I'm going to divide each one by that number. And I'm going to end up with 1, 1, and 2. So now, I'm going to see this, and I'm going to write carbon, hydrogen 2, Cl. And that is your final answer. So this is just a short tutorial on writing empirical formulas, not only from grams, but also from using percent yields, or percent composition, sorry. If you are struggling with the grams to mole conversions, please use the past videos on how to convert from grams to moles. And also make sure you're doing practice problems if you still need help with empirical formulas.